This is a video that's going to start to introduce bond polarity and molecular polarity. So the difference between electronegativities is what determines what kind of bond type we have. So if hydrogen and hydrogen both have an electronegativity of 2.1, so obviously the difference between them is 0. So 0 to 0.4 is going to be a covalent bond, and nonpolar means that they're sharing equally. Polar covalent bonds, the difference between 0.5 to 2.0, now they're not sharing equally, and we're going to start talking about that a little bit more. So chlorine has an electronegativity of 3.0, hydrogen is 2.1, so the difference between them is 0.9. And then what we're going to talk about is called a bond dipole. And you can see this little cartoon, the electrons in the bond are being pulled by the chlorine more than the hydrogen. So we're going to show that with what we call a dipole arrow. So a dipole is either there's a dipole that can happen within the whole molecule or in the bond of a molecule. And it's where you have a positive end and a negative end or region. So a dipole we're going to use is with an arrow and then a little tail. And the tail is, positive. Kind of you can see the positive here. And then it's going to point towards the higher electronegative element, and then away from the one with a lower electronegativity. So if you have like hydrogen bonded to fluorine, this is 2.1, 4.0, so difference is 1.9. Again, it's even more polar than the HCl, but we can show the dipole along the bond. We would draw the arrow pointing towards the fluorine because the fluorine's going to pull those bonded electrons towards itself and away from the hydrogen, which causes the hydrogen to become partially positive. Another thing sometimes you'll see are these delta signs, which are partial. This means partially positive, partially negative. So you're going to do the PHET today. This is an awesome PHET, and you're going to see bond dipoles, and in the PHET they are black, so I think you have to turn them on, but you'll see like here the oxygen is pulling these electrons from this hydrogen towards itself, and then this bond here, again, the oxygen pulls. There's also something called a molecular polarity. If I look at the whole molecule and think of it like draw a circle around it, this end is negative and then this end is positive because there's going to be a buildup of electrons kind of on this end of the water molecule. And you are going to play around with the PHET and see, one of the ways is with the electron density button. The red will indicate that there's more negativeness or more electrons in that region. So in the PHET, there's also going to be a molecular polarity, a molecular dipole. So it'll be gold colored. And then if you see that, I wish I could make mine gold, but the gold arrow is going to show you whether or not overall that whole molecule is polar. Is there a negative end and a positive end in the whole molecule? Versus the black arrows are just telling you that particular bond, whether there's unequal sharing. So one more thing, I'll just kind of take you to the PHET and then just get you going on it. So you're going to be doing the PHET and doing an assignment that goes with it. The PHET, you're going to work your way through the directions. You're going to do 2 atoms, and you can change electronegativity. You can show the density differences. Here's that bond dipole, and eventually, the last part, you're going to go to real molecules, and when you have to click on this orange, it used to be Java and now it's this chirp. It helps you to run this. The other two were HTML programs. I don't know if I'm using the right terminology, but so this one works a little differently, so it might take a little bit. And I'm going to pause the video. So here's that hydrogen fluoride that we were just talking about in the slide deck. And if I click on the bond dipole, I can see it's kind of a gray, not really black, pointing towards the fluorine, which has a higher electronegativity. And then overall, this molecule also is going to be negative on this end because of this gold arrow, and then positive on the other. I can put in the partial, those are the little deltas, you know, the partial negative and partial positive. They give you a number. We're not really interested in the number. Or we can also look at the electronegativity values. I like to play with these, where you can then see with the color, the red is the end that's negative, and this is definitely a polar molecule, and the blue is the positive. You can also use the electron density, which is similar, but it gives you the shading. So it's darker where the electrons are more, so which would be always the negative end. So if it's a polar molecule, you'll have that yellow dipole arrow.